announcement which is regarding the phase 2 of the assignment. Phase 2 has already been uploaded. Small assignment, and the last date for submission of the phase 2 is also 20th November. Right, so please, since we are having the regular examinations on 24th, 25th November, there is no scope for extension of the phase 2. So a request that the same should be uploaded by 20th November. There will be no extension. The link for uploading 2 of the assignment will be available from Monday. A revised list of the groups will also be uploaded by Monday, and there will be some shuffling in the sets to which you belong, because there have been many groups where the students have changed the groups. So a revised list according to your submission will be uploaded, and please look out for the set you belong to. So might be a change in the set in which you belong to. So for the set which you belong to, and then make the submission of the phase 2 accordingly. You now submit in the revised set to which you belong. This will not affect your phase 1 submission. Right? Your phase 1 submission, based on your phase 1 submissions, your sets have been organized, and if you are moved into another set, your submission is being moved to the other set. Right? So please, this that you submit must be in the correct set. Right? As per the new list that will be uploaded on Monday. This question whether there will be quiz 3. No, there is no quiz 3 in this course. We end with quiz 2, and then that would be followed by phase 2 of the assignment, and finally the comprehensive examinations. The expected deliverables for phase 2 is mentioned in the document itself. Kindly go through the same. If there are any queries, you can write a mail to me. I would definitely try and answer it. Start today with the lectures today. Okay, so we still have a few of the grasp patterns to cover. Right? 9 patterns. 5 patterns is what we covered in the last lecture, and today we're going to cover the rest of those. So the first pattern that we're going to start with today is the controller pattern. So let's see what is the problem the controller pattern tries to address. The problem is first object beat the UI layer receives coordinates option. Okay, quest slides are not visible. Shared, have open and shared. Is it not visible? Okay, give me a minute. I'll open again. Okay, visible now. Getting 1, yes. And the others are no. Visible? And the slides are not visible. That's a tricky thing. Visible? Okay, I don't know why is it not visible. In the same way. Okay, so we start with the controller pattern today. Let's understand the problem that the controller pattern tries to address. It says, what first object beyond the UI layer receives and coordinates a custom operation, right? So which should be the object, right? The first object which receives all these custom operation events, right? If you remember when you were working with the snakes and ladders case study, we came up with the a concept which was game, and then later we transformed it into the class diagram, and we transformed the domain model into the class diagram. There was an intuitive class that we all had made which was called the game controller. There was a main reason behind that game controller, the class that we came up with, the game controller. Knowingly or unknowingly, the pattern called controller pattern was something that was applied and in that particular case, right? Because we always felt that there's a need of some kind of an object that should be responsible for controlling all the that are coming to the system, and hence we came up with a concept called the game controller, and very nicely we gave it a name also, which is game controller. I knew that this is something that we are creating in order to control the entire green processes, right? So this was an object, the first object beyond the UI layer, right? So it is of course the user interface layer which receives the first input from the users, right? But beyond that layer, at the system level, which is the first object which is responsible for controlling all the system operations. And this was the controller. So our controller is the first object beyond the UI layer which is responsible for handling a system operation message. And the solution that the controller pattern provides us is that assign responsibility to a class representing one of the following choices, right? So which class should be responsible for handling all the inputs from the user? You choose in one of these two ways. Either a root object or system that controls the major or all the system operations. Right? We need a common root object which is responsible for handling all the events that are coming to the system. Right? Make use of a class which represents a complete use case scenario. Right? So you have one major controller which is the main root object, or you might have a number of controllers and you name them accordingly. So a controller which is responsible for handling events pertaining to a certain use case scenario, you name it accordingly. Right? You might call it use case handler, or this particular use case coordinator, this particular use case session manager, or maybe manager. Right? So these are the objects which are responsible for handling the events which are coming to the system and processing them. Right? So what do we mean by a controller processing the events coming to the controller object? Right? What is the responsibility of the controller? A controller is responsible for delegating to the other objects the work that needs to be done. Right? So the main task that a controller is supposed to do is coordinate or control the activity. And this is what we say is the task of the controller. The controller has to delegate the task to the other objects. It does not do much work itself. Right? So this is one very important concept. The controller should not do the tasks on its own. The controller is to be designed in a manner that it only delegates the tasks to the other objects, right? And if a controller has designed in a way that it does not delegate the task and keeps on doing all the tasks on its own, it is called a bloated controller. A bloated controller is a poorly designed controller having low cohesion, unfocused, and handling too many areas of responsibility. Right? That is what we say that the controller itself should have cohesion. So by bit of high cohesion for a controller, we mean that it is supposed to do only the controlling task, right? It should not be responsible for doing the task on its own. And in case a controller is designed to do the tasks on its own, then it is called a bloated controller. It is not doing the task specifically for the controller. Right? So let's take up a few examples and understand. From snakes and ladders example, it is very clear that the game controller is the one that is responsible for controlling the tasks of the system. Right? So if in the snakes and ladders case study, we ask who should be responsible for sending invite to a player to join the game. Right? The answer would be responsible for sending invite to a player to join the game, or who would be responsible for informing every of the players that this particular player has won. Right? So if you see these particular tasks, they are the tasks which are related to the entire game system. All these tasks which are related at a higher level, related to the entire game system, they are to be done by the game controller. That is the reason we effectively, unknowingly, we placed some concept name as a game controller inside the class diagram of the snake ladders case study, right? It came intuitively. Everybody said that the game domain concept has to be converted into somebody who handles the entire system, and that was the game controller, right? You could name it as a game handler, you can name it as a game manager, but this is the main class. Beyond the UI layer is the class responsible for handling the various system events and delegating the tasks that are to be done to different classes existing in the system. So this is what a controller pattern tells us, that whenever you are designing a system, it is very important that you have a centrally placed concept, a controller or a handler, which does most of the deletion task, right? In case you do not have this kind of a controller, the external events get segregated and they are being sent to the subsystems by the client, right? So then if something has to be changed, it will be really difficult to find out which subsystem the event is going to. But if you have a controller play at the top layer, easily find out, okay, the controller is sending these events to this particular subsystem, and these events are being sent to this particular subsystem, right? It is, if I can draw an analogy of this pattern with one of the gang of 4 patterns, you would understand that this pattern is somewhat closer to the facade pattern that we discussed in the gang of 4. So the facade pattern also aims to put up a main system which kind of the various other subsystems that are there in the entire system and takes the responsibility of sending messages or delegating tasks to the various subsystems that are there in the system, right? However, that is at a higher level where the subsystems might be distributed subsystems, right? Whereas in this particular case, we are talking about a small system itself, where in itself we need a controller class in order to handle all the incoming incoming events, right? The question, is it anywhere related to MVC pattern, right? So these are all variations that have been proposed by various researchers. It is quite close to the MVC pattern if you see. So in the MVC pattern, you have C, which is the controller, right? So in that case also, it is the controller is designed to handle all the incoming events and then delegate them further. So all these derive from the same concept, that there has to be a controller which is responsible for handling the system events. I'll just take up a few questions. It says in the main model that we had drawn, the game owner is responsible for inviting the players, right? So conceptually it was the game owner who would invite the players, but it is actually the game controller who would be doing it, right? So the game owner will not be directly involved in inviting the players, because if the game owner directly invites the player, then the game owner has to store the information about the players, right? Which is incorrect, which will lower its cohesion. Right? So it is the game controller to whom the game owner also joins, right? And once the game owner joins the game owner sends a request to the game controller to send invites to the other players, so that the other players also join the system to the game controller. Right? So owner directly will not be inviting the players to join the game. Okay, this was about the color pattern, right? Let us move ahead and we'll take up the next pattern. This pattern that we have here is the fabrication pattern. So there's one more question for the controller regarding the controller pattern. Does it mean that the controller enforces single entry point beyond the UI layer? Yes, the controller enforces a single entry point beyond the UI layer. So beyond the UI layer, after the UI layer, all the system events are directed to the controller, and the controller is supposed to delegate the rest of the functionality to the other modules. Right? Okay, we'll quickly move up to the pure fabrication pattern, since we have a lot of patterns to cover today. This is another grasp pattern. Right, so the pure fabrication pattern tries to address the problem, which is what object have the responsibility when you do not want to violate high cohesion, low coupling, other goals, but the solution offered by the information expert are not appropriate. Right. So the problem here is that the solution offered by the information expert is not the best solution. Right? Not an appropriate solution. In case, how you should assign the responsibility for doing a particular task. Right? We would try and understand this with scenario, and then only we understand that why the solution offered by the information expert is not appropriate, and we need another class to do that. Right? Let's first understand the solution it tries to provide. It says the solution is assign a highly cohesive set of responsibilities to an artificial or convenience class that does not represent a problem domain concept, right? You are assigning a highly cohesive set of responsibilities to a class which is artificial. So what do you mean by artificial? That this class does not represent a problem domain concept. So this class does not exist in the domain model. It is a fabricated class, it's an artificial class, and it is a convenience class, right? It is being created for a particular reason, right? And it is made up to high cohesion, low coupling, and enhance reusability, right? So I'll just give you an example. So the example of pure fabricated class would be like database manager class, right? Suppose my system, so say let's consider my snakes and ladders case study, right? So there are a large number of participants there, a large number of players that are there. So maybe there are 4 players at the same time who are playing the system, and I store all this information about the players in a database. That is, who should be responsible for writing the information to the database, right? It could be information related to the player's current position, number of coins, the color of coins, etc., etc. Right? In this particular case, if we go by the information expert, this pattern tells us that whoever has the information is to be written in the database should be responsible for doing the same, which is not the right thing to do because it will violate the cohesion principle. If I make every player interact with the database, connect to the database, and then write to the database every time the player moves, right? It's an incorrect thing to do because you're violating the cohesion principle. The player itself is to only do the tasks which a player should do. It should not be interacting with a database and writing data into that. Right? As per the information expert pattern, because the player has the information which is to be written to the database, let the player do it. In this case, we need a new class, which we call a fabricated class, an artificial class, in which we put all the activity, all the tasks which are related to the interfacing with the database. Right? We might name it, give it a nice name so that it is understandable. So we might give it a name, say database manager. Now this database manager is the one that should be responsible for writing all the data to database. Right? So this class will open connection with the database. Whenever the player moves, the database manager takes the information from the player, because the information expert is the player in this case, and then writes it to the database. Right? So this particular fabricated class, if you see, becomes highly cohesive because this class does all the database related tasks. It only takes the information from the other classes which have the information which is to be written to the database, and it writes the information to the database. Right? A few questions. Let me pick up that so that I make it more clear to you. Third, for writing database inside the class, then cohesion, I get the word, continues. Okay, the idea that I'm trying to explain is that every class inside the system should not be interacting with the database and writing information about itself in the database. Right? This is a general rule that we do follow, but how does that rule come from? Is from this particular pattern. If every class that has the information, for example, the player class has the information about its current position, the player class will not connect to the database and then invoke a method and write the data to the database. Right? It is lowering its cohesion because the player class now starts doing some unrelated task. The player is supposed to represent only a player and not do a task in which it interacts with the database and writes information to the database. This, although being an information expert, although knowing what is to be written into the database, the player class will not write that information to the database. Right? Somebody else has to write the information into the database. That somebody else will not be the game controller, because the game controller is has only the task of delegating the events. Right? So in order to complete this task of interacting with the database, we usually fabricate a class which is given only the responsibility of interacting with the database and writing data into the database. Right? So this cohesive set of responsibilities of only interacting with the database are put into this fabricated class, which is not a part of the original domain model, but it has been created for completing the task of writing information into the database. I'll just take up a few questions so that I know where we are in terms of understanding. Consider that case the player class can interact with the fabricated class. Yes, the player class will be able to interact with the fabricated class. By fabricated class, the whole idea is that it is an artificial class created which is not a part of the domain model, and it does not represent any particular entity of the system, right? So it has been fabricated for completing a set of cohesive tasks which, if placed into individual software entities, will reduce their cohesion, right? This is the classes of data access layer. You can say that this pattern is creating a wrapper class. Precisely not. It would not be a wrapper class, but it's a class which is responsible for interacting with the database. So all the tasks which are assigned to all the tasks of interacting with the database are put into one particular class which is responsible for only doing that particular task, right? So in case I give you an example, one of the important advantage of this particular pattern is that in case we want to move from a database X to database Y, right, in that case it is only the database manager class that needs to be changed. The rest of the classes are not affected by this change, right? Advantage of making a different database class and which is responsible for doing this particular cohesive set of responsibility. Can I say that adapter in the adapter pattern is a fabricated class? It is a fabricated class, right? Because it is created out of fabrication for n particular reasons, right? But you cannot say that if you create a fabricated class using a pattern, it is an adapter pattern, right? So the two concepts are largely different, right? I've got a few questions here. So who would be responsible for writing scores into the database, right? This was the question, this was the scenario that we have discussed throughout to understand the pure fabrication pattern. So in case of snakes and ladders example, who would be responsible for writing the scores into the database, right? And the answer is that we would use another class which would be responsible for writing these scores into database, right? Please do not make the game controller do this task, right? The game controller should not be converted into a blotted controller where it does most of the task itself. Game controller will only delegate the tasks, right? So let's have another class which is responsible for interacting with the database and writing all the data to database. Right? Just think, what if the snakes ladders game converted into a distributed game, right? So all the players, they are placed at different locations. They can connect online, right? So in that case, definitely we would need a database where we need to store the information about the scores of various players, right? So in this scenario, you would understand how important it becomes to write these scores into the database. and then this particular task would be carried out by another, which is a fabricated class, which is being invoked by the game controller to write the information into the database. Right? But game controller will not be responsible for writing or interacting with the database. Right? The next question is, if two dices are used, okay, so if in the snakes and ladders example, there are two dices, right, and this is the case when this other case in which this is another way in which you can even play games like snakes and ladders and ludos. So instead of having one dice, you have two dices. So if there are two dices that are being used, who should be responsible for obtaining a total of the face values obtained in each dice? So again, example of a pure fabrication pattern where I need somebody to tell me that if there are two dices, how will I be able to know the total of the face values obtained in each dice, right? And this is case we would need a fabricated class which is called a visible now, right? So in this case, we need another fabricated class which is called a cup, which would be responsible for finding the sum total of the two dices when the two dices are rolled, right? So instead of rolling the dices, in this case, now the players will interact with the cup only, and the cup, and will say, and they will either invoke a method, say roll cup, or they would invoke a method get the face value from the cup. Right now, internally, the cup is the one which will be responsible for the two dice and returning a value to the user. Right? You might think that this is not a very nice idea of having a cup to put the dice, but think if I want to add another dice to it. Right? So if I add another dice, then having a cup to that for me is a good idea, because then in that case you can add as many number of dices as you want. These fabricated classes, they might be a part of the system, but might be fabricated in order to fulfill particular set of responsibilities which are if done by the information expert, lowers the question of the information expert. Right? This is one main reason why we go for a pure fabrication class, is that the solution offered by the information expert lowers the cohesion of the particular class, and that's the reason we fabricate a new class. Assign the responsibility to a particular class to do the designated set of responsibilities which are highly cohesive in themselves, and then do the task. Right? So this was the pure fabrication pattern. So we've covered two patterns, controller and pure fabrication. Move to the next pattern, is the polymorphism pattern. Right? So this polymorphism pattern help us to solve the problem as to how to handle alternatives based on types. Right? So if there are n number of classes which differ in type, how to handle these various alternatives. the problem continues is that how to create pluggable software components, right? And the solution, it says, is that when related alternatives or behaviors vary by class or type, assign responsibility for the behavior. Polymorphic operations to the types for which the behavior varies. And one of the example of this particular polymorphism pattern is a common interface that we create for the adapter pattern, or the common interface that we create for the observer pattern, right? So the polymorphism pattern to explain almost the same concept, the one that we understood using quotes to an interface, which it says that if there are alternatives which might vary depending upon the type of the class, they always assign responsibility for the behavior. Have a common interface. Various alternatives should implement that common interface. And these alternatives, different types of classes, would change on runtime, but the interface remains the same. And this one kind of an example we saw even in the factory pattern, where we had a cake factory. I hope you remember. So we did the factory pattern, and when we made a cake factory, and factory was supposed to give cakes of different types, right? So there were, say, 4 types of cakes that were there, and we saw that the common interface that each cake was implementing, and this interface, which was the cake itself, had the behaviors that a cake, the methods that in which a cake would be prepared, right? So if I remember correctly, so there was a decorate cake, there was a bake cake. So bake cake was before the decorate cake, and then also the box cake, right? So there were 4. I'll just take up 3 of them this time, right? So the interface was different in terms of a cake, the way it has to be prepared, the methods, the behavior of the cake, the way the cake is to be prepared is put into one interface, and the rest of the types are responsible for implementing this particular interface. So it is the common interface that helps us to handle the alternatives objects that might exist at runtime. So all these patterns, all these ideas where we say either polymorphism, or we even say here code for an interface, all these ideas take or lead us to one common concept, wherein it says that code for an interface always have the behavior exist in terms of an interface, and let the rest of the types implement this particular interface, right? If you do that, you are able to achieve various other patterns, various other concepts with this whole idea. Try and explain the same using the observer pattern, right? So in the observer pattern, the observer pattern, the observer interface is the one that is constant, right? So the observer interface represents a behavior which is update. number of concrete observers can come up, different types they may be, and implement this observer interface. Right? So the subject need not know what the other concrete observers are. They only need to know that there is an observer interface which has an update pattern, right, which has an update method which needs to be notified. Right? This is another way that polymorphism pattern is being implemented. The observer is the common interface. The types will vary depending on the runtime. The concrete observers, whatever type may be, all of them implement the observer pattern. And the concrete subject simply needs to notify all the observers which implement the common interface through the update method. It need not be bothered as to what is the types of concrete observers that are existing. Right? Okay. Is there no interface diagram for the grass patterns? No, there is no typical diagram as you find in the Gang of Four patterns. There are no typical diagrams that exist in the patterns. Question is, polymorphism pattern is like implementing interface. Yes, polymorphism pattern is like implementing interface. The whole idea is that introduce polymorphic behavior so that you can attach or you can address alternatives change based on the types. Right? Is implementing the polymorphism pattern. Okay, this is another question slightly related to the assignment, but I'll still take up this. So for assignment phase 2, what diagram for the grasp ones, right? So you do not have to give the standard diagram of the pattern. You're supposed to give the diagram related to your own case study. How or in what manner are you implementing that particular pattern in your case study? Right? So the class diagram or the diagram containing the software objects of your own case study and give an example of how a particular pattern is being represented in your particular case study. Has to be case study specific. And a question. Okay. Will be the results of phase 1B of the assignment be out. We'll give the consolidated marks after the vivas of the phase 2. Right? And there was a question regarding the viva. The vivas will only be an interaction mechanism to understand your understanding of the case study, the designing, and your contribution. Right? So please do not think of it being a very heavy viva. It would be only an interaction to understand your understanding of the results of the assignment. Right? So polymorphism pattern, and then we have action pattern. There's a question, polymorphism pattern will be used almost in all OOAD cases. Yes, it will be used in case you actually use it. Right? So if you might design using concrete classes without the use of polymorphism, which is the way we actually do, we start designing classes, then in that case, of course it will not be there, right? But it does make itself uh, an important candidate to be used in most of the possible cases, right? Designing using an interface is the best idea to make your system more extensible. Move to the next pattern, which is the indirection pattern. Now these three patterns, which is the polymorphism, indirection pattern, and the variation pattern, right? All these three patterns are quite close to each other, right? So they may be trying to solve a problem which might be worded differently, but in a way they lead to each other, right? The indirection pattern, let's understand the problem that it tries to solve. It says when to assign a responsibility to avoid direct coupling between two or more things, or how to decouple objects so that low coupling is supported and reuse potential remains higher. Right? So the problem is how to reduce the coupling between two modules or two systems. So if there are two systems which are directly using each other and they are highly, as a result of which they are highly coupled, because of which a change in one of the system leads to a change in another system, how should one go for reducing this coupling, right? The solution is assign responsibility to an intermediate object to mediate the interaction between these two highly coupled objects, right? And examples of the action patterns are start, observer, pure fabrication, right? All these are ways of introducing an intermediary object or intermediary fabricated class which reduces the coupling between the two objects, right? For example, if I try to understand how is observer an example of indirection pattern, I only use the concrete subject, and if I only use the concrete concrete observer, then the concrete subject needs to keep information about all the concrete observers existing in the system, right? We decouple this connection between them by introduction of an interface which is the observer interface, right? So the concrete set now only needs to keep information about all the alternatives which are implementing the observer interface. So in a way, the coupling interaction between them gets reduced. So even if I remove a concrete observer from the system, my concrete subject is unaltered. Even if I add a concrete observer to my system, my concrete subject is unaltered, right? So that is a way of introducing a induction. That means you are introducing an object which is reducing the coupling between two particular objects. Right? So this is how observer pattern is an example of implementation of the indirection pattern as well. Similarly, if we can even take for a facade pattern, again facade pattern, it forms a kind of a decouples the various subsystems from the outer system. Right? So the outer main system or the clients which are trying to access my system, they are being indirected, or their coupling is being reduced with the subsystem. So they no longer interact with the other subsystems, but they only interact with the facade object, right? So a layer of direction is being introduced between the client and the subsystems in my system. Right? So if a particular subsystem changes, my client is unaltered. Right? It will be the facade which is to be changed, which is to be redesigned to accommodate the subsystem. The client is decoupled, right? So my client is only interacting with the facade object. So this kind of indirection helps to introduce an object between heavily coupled objects so as to reduce the coupling between the two. Very close kind of a pattern is the protected variations pattern. Right? And this is the last of the grass patterns. The problem that this particular pattern tries to address is that how to align objects, systems, and systems so that variation or instability in these elements does not have an undesirable impact on the other elements. Right? The idea is protected variations. How do you protect the variations from having a ripple effect onto the other systems? And the solution is identify points of predicted variations, possibilities of instabilities, and assign responsibilities to create a stable interface around them. And the best examples of these are polymorphism and indirection. So the moment you find there is a possibility of variations happening in the subsystems, create a level of indirection on top of it. That the effect of the changes in the subsystem does not get rippled to the other systems, to the higher level system. This layer which decouples my subsystem with the other system, right? So that if there is a possibility of the subsystem, it doesn't have ripple effect on the rest of the systems, demanding a change in rest of the systems as well, right? And there's a question, why need variation patterns if we already have an indirection and polymorphism as the grass pattern, right? These patterns, the reason is that the whole idea, that the whole problem that they attempt to solve is slightly different. The solution may be the same, right? But the problem is the problem domain that it is trying to solve is slightly different, right? So you can go through the problem each one tries to solve and understand in a better manner. The solution is the same, but the problem that each of these patterns tries to solve is slightly different. I think we will take a break here. I'll stop the recording and we'll come back after 5 minutes.